All right, now we're going to take a look at using slope-intercept form and linear equations to solve word problems. We're going to come up with a systematic way to solve word problems. We've done guess and check. We've made tables for some word problems to come up with some solutions. But now we're going to write a two-variable x and y equation that will generate any possible input and output solution to solve a problem. Okay, so remember, y is equal to mx plus b. M is equal to your slope, and b is equal to your y-intercept if you're talking about the visual aspect of it. Okay, how does that help us in a word problem? Well, the slope, we're going to assign the slope to any rate of change in the word problem. Any rate of change. Okay. And B will be the y-intercept will describe where the person started or where the money started or where the investment was or whatever the starting point was. If it was 2 runners, the starting point would likely be 0 because you have run 0 miles. Okay, and we'll get more into that. Okay, so basically there's going to be 2 numbers in each problem. One is going to be the rate of change, and we're going to call that the slope. And the other one is going to be the y-intercept, or where the word problem starts. Let's get an example. This will probably make a little more sense. So example 1, it costs $50 to rent a park pavilion plus an hourly rate. There we go. There's a rate of $10 per hour. So let's write an equation in slope-intercept form that shows the cost y, the output y, which is what we're going to generate, for renting the pavilion for X hours. So the output is how much money it's going to cost us. The input is, well, how much time do we want this park pavilion for? Let's say it is someone in our class's birthday, and we need a park pavilion to have this little birthday shindig. Okay? So remember, y is equal to mx plus b. So m is going to be your rate of change, your $10 per hour. And b is going to be any constant that it gives us in the word problem. So what is going to be the constant? Well, it costs us our $50 down payment that we do not get back. That is not going to change at any point in time. So y equals the slope, which is $10, times X hours, which we don't know how many hours we're renting it for, plus let's say a fee or a down payment of $50. So y is equal to $10 times X plus $50. And that can help us. That is just basically written a formula for any possible input and output that we could ever rent this park pavilion for. Okay. So what is the cost of renting the pavilion for 8 hours? Y equals, okay, y is the output money, $10 per hour plus 50. So we have to determine, is 8 hours, is that an input or an output? Well, we don't get out time. If we're renting something, it's going to cost us money. So we have to solve for y when we know that the input is 8 plus 50. And I think you can simplify this probably in your head. 10 times 8 is 80 plus 50. It's going to cost us $130. All right. So there's one quick little example. Right. Let's draw a graph to represent the equation that we wrote. All right. So y equals, once again, it is, I believe it was 10x plus 50. 10x plus 50. And this is just a first quadrant sort of graph here that's going to help us. So where do we start? Where is our y-intercept? Okay. Well, no matter what, at hour 0, before we've paid anything, before we partied at all, before we've used this park pavilion, it's going to cost us $50. Let's put a point at $50. And after 1 hour, it costs us $50 plus 10 more. Okay, so that's going to cost us $60. And after 2 hours, it's going to cost us $70. 3 hours, it'll cost us $80. 4 hours, it'll cost us $90. You kind of get the picture here. This is a linear growth. It is going up by $10 every single hourly unit. And our graph will be right here. So in red, y is equal to 10x plus 50. Perfect. Okay. But how about this? Suppose at another park, you can rent a pavilion for cheaper. It's only $5 an hour, but it's going to cost you $80 for the down payment. how long do you have to rent this pavilion before it becomes a better deal than the other park? So if y is equal to mx plus b, let's write an equation for this pavilion's cost. Okay, so our hourly rate is 5. That is once again going to be our slope. And the $80 is going to be our b, our y-intercept. So y is going to equal 5x plus 80 in this particular case. Now we're going to go backwards and we're going to graph 5x plus 80 and see how these things differ. Okay, let me get out a different color. I'll call it purple right now. So at hour 0, it's going to cost us $80. But hour 1, it's only going to cost us $5 more. So I'm going to put a little dot right here at 85. Okay, this is going to be, write the equation, y is equal to 5x plus 80. And at 2 hours, it's going to cost us $90. 3 hours, it'll cost us 95. 4 hours, it'll cost us exactly 100. And then this slope will continue. And this point right here is a very interesting point. So going back to the question, at which point in time, how long do you have to rent this pavilion before it is a better deal? So obviously we rent it for 0 or 1 hour. I don't know why we'd rent it for 0 hours, but 1 or 2, it's a more expensive deal. But if I have to party at Christian Storch's birthday party for 8 or 9 or 10, 11, 12 hours, he's a party animal, okay? We are going to have to go with the purple deal. We're going to have to go with this cheaper park, this other park, because at that point in time, the line is underneath the red one, and it is the better deal. I hope this kind of helps a little bit with the word problems and slope intercept